Hello everyone. Today we will be continuing our discussion of apportionment with two new methods that we'll discuss, and these are Adams's method and Webster's method. Now, both of these methods, similar to Jefferson's method from the last video, are what we call divisor methods. They are apportionment methods that rely on using a modified divisor relative to the standard divisor to calculate new quotas, which are then used for the actual apportionment of seats. So the first one that we'll look at is Adams's method. Now, Adams's method is essentially, in a way, the reverse of Jefferson's method. Rather than picking a divisor lower than the standard divisor and giving everyone their modified lower quotas, we are doing the opposite. We are picking a divisor that's higher than the standard divisor and giving everyone their modified upper quotas. So to start off, I have our standard quotas and our standard upper quotas that we get from rounding up all of these standard quotas. And what happens if we add up all of the upper quotas with the standard divisor of 1,000 is that we end up with 102 seats. So basically what we're going to do is we're going to raise our divisor so that we are basically causing all of the quotas to go down until we eventually have right at 100 seats. So similar to what we discussed with Jefferson's method, this new divisor is determined with kind of a trial and error method. So we will try a divisor of 1025. So this is Adams's method with our divisor of 1025. So if we, in our calculators, divide all of these by 1025, then what we end up with is modified quotas of 4.78, 30.44, 37.66, 15.32, and 9.37. So these are our modified quotas for each of the 5 states. Now we're going to round all of these up to get the modified upper quotas. So this is going to give us 5, 31, 38, 16, and 10. Now, at this point, we basically just are going to add up the number of seats with the modified upper quotas, and what we find when we do that is that we do end up with right at 100 seats. So in this case, we can use this number of seats as what we apportion to the different states using Adams's method. All right. The other method that we will discuss today is Webster's method. Now, Webster's method is kind of, in a sense, a compromise between Jefferson's method and Adams's method. In this case, we are still using a modified divisor, but once we get the modified quotas, we are going to use conventional rounding to figure out the number of seats for each state based on that. So I have written here the rounded standard quotas for all of the states, and as it turns out, if we were to add all of these up, we would have 101 seats. So what this tells us is that we need to actually raise our divisor a little bit. And the reason for that is we want these numbers to basically go down until this total ends up being only at 100. So we are going to pick a divisor that is higher than our standard divisor. So this is Webster's method. And we are going to guess a divisor of 1010. So if we put all of these into our calculator, divide all of these by 1,010, then the quotas that we end up with are 4.85, 30.89, 38.22, 15.55, and finally 9.51. So now what we're going to do is we are going to take all of these new quotas that we just calculated, and we are going to round them to the nearest whole number. So in this case, 4.85, that rounds up to 5, 30.89 up to 31, 38.22 down to 38, 15.55, that's going to go up to 16, and then 9.51 is going to round up to 10. And if we add all of these up, then what we're going to end up with is right at 100 seats. This is how we can assign or apportion seats using Adams's method and Webster's method. Thank you for watching, and as always, I'm happy to help with any questions.